2.6 intersection of planes. If we have two planes, there are three possibilities. The two planes intersect each other and a line they have in common. If this line is common between these two planes, then we have infinite solution. Or two planes are coincide, again, the infinite solution. But these two planes are parallel means no solution. Make sure when there's a line, there are so many points on the line because so many points is going to be infinite. There's so many points they have in common here. It's going to be infinite solution. So these are the process that we have to take. We check the normals of the plane, if they are parallel or not. If they are parallel, therefore, could be two cases, right? They are parallel, they are going to be distinct, right? Or they could be coincide, like both of them are the same. If they are coincide, infinite solution is distinct, no solution. So if you use the process of elimination or substitution, you get 0 over 0 equal to 0. So this is going to be infinite solution. That was going to be this case. If you do the elimination and substitution and you got a number equal to 0, of course, this is not hold on. The two parallels are distinct. So it would be this case, no solution. But if these two planes are not parallel, so this will be this case when they have a line in their common. So use the process of elimination, resolve the line of intersection. You need to assign a variable to a parameter and find the other and further x and y or z in terms of the parametric equation of the line, and then we can write the vector equation of that line. Let's just do a question. So here is the plane 1 and here is plane 2. Look at the normals. 3, -1, 2. For this one is 2, -1, negative. So the coefficient of this is -1. So there's a typo here. It's -1. As you see, they are not multiple of each other. They're not parallel, right? Therefore, you need to use a process of elimination. So you're taking the first one and second one, you can eliminate y, multiply this one, the first one by 2, and then minus them. 6 minus 2 is 4x, -2y minus -2y, they eliminate y. And positive 4z minus z is 5z, -8 minus 3 is -11. So this is what we have. Instead of the x, we put parameter t, x equal to t. Then we put, for example, instead of the x, we put t, and then we rearrange it for z. So z is -11 over 5 minus 4 over 5t. Now we take the original one. Let's say we take the second line, 2x -2y z minus 3. And then instead of the x, we sub t that we had before. Instead of the z, we sub -11 over 5 minus 4 over 5t. We expand, simplify, and we rearrange it for y. This is y. Then I just put it the parametric equation of the line, x equal to t. Y is given in terms of the t, z is given in terms of the t. Then I can write the equation of the vectors. Remind you that it's going to be 0, -4 over 10, -11 over 5. That's going to be point. And the equation of the t is 1, 14 over 10, -4 over 5. This would be your normal vector. Sorry, directional vector for that line. Here is another question. 2 planes given. So the normal is 2, 3, -7 is here is 4, 6, -14. They are multiple of each other. So they are parallel. They are parallel and they are distinct, right? So but we can try to find it out. So you multiply the first one by 2. Or you can divide the second one by 2, right? Divide this one by 2, you get 2x plus 3y minus 7z divided by 2 is going to be 4. And you just copy down the first one, you eliminate. So 2x minus 2x is 0, 3y minus 3y is 0, -7 So -7 -7 says 0. 4 minus 2 is 2. So at this side we have 0 equal to 2, but no 0 cannot be equal to a number. So this is wrong. So we can say that there is no solution. Or these two are parallel. These two planes are parallel, of course, and distinct, right? Therefore, there is no point of intersection. As you see, if you multiply the first one by 2, you don't get the second one. So it's parallel and distinct. Or you can do the elimination and get to that conclusion. So here, the next one is intersection of 3 planes. So there are when we have a solution, it's 3 cases. Now, these 3 planes have a common point, just one point in the common. So the normals are not parallel and is not coplanar. We'll talk about coplanar later and to see what is the coplanar. Here, they intersect there. They have a line of intersection for 3 of them. So going to be infinite number of solutions. The normal are coplanar, but they are not parallel. And they are coincide. Of course, infinite number of solutions. The normals are parallel. And there are 3 cases that there is no solution. And 3 of them is parallel and distinct. Here, 2 of them are parallel and the other one is not. So again, no solution because you need to have a common between 3 of them. This and this has a common in line, this and this has a common line, but 3 of them together, there is no common at the same time for 3 of them. And this one is 2 by 2, they have a intersect section of a line. So overall, we don't have any point in common for 3 of them. 2 by 2, they have a line of intersection. So here, all normals are not coplanar, but not planar. So they are coplanar. As you see, this case is coplanar, and case 2 from here is coplanar, and here, check normal of. So if you want to do the process of that, we need to first check normal of the planes, if they are parallel or not. So if they are parallel, it's 2 cases. They coincide, like I was saying, or they are distinct. So they are distinct, no solution, but if they are the same, of course, it will be infinite solution. If they are not parallel, we have to check if they are coplanar or not. Coplanar means you have 3 normal of normal vector to each of these vectors, each of these planes, and 1 dotted to N2 cross entry. So if you cross product to 2 of these normals and dotted to the third one, if this the result is 0, so they are coplanar. So if they are coplanar, therefore you have a line of intersection, infinite solution. If they're not coplanar, so the plane could be intersect at a point or intersect lines in pair. If we solve algebraically for x and y and z, we will find a point. It's going to be one solution. And if we don't find any point, would be no solution. So let's just look at this question. We have 3 planes. The normal of this is 1, 1, 1. Here is 2, 1, 3. Here's 2, -1, -2. As you see, they are not multiple of each other. They are not parallel. We need to check if they are coplanar or not. So take N2, cross it to the entry. I hope you remember how to do the cross product. And then the result, you dot it to the last vector. So we see that it's not coplanar. Therefore, it could have a point of intersection. We use the elimination. So we take first one and second one here. And here we take second one and third one there, right? First one and second one, we minus to eliminate y. So 2x minus x is x, y minus y is cancel. 3z minus z is 2z. And here, negative 17 to the other side is 17. So it's going to have 17 minus 7 is 10. And here again, because we eliminate y here, we eliminate 1 and eliminate y here. If we add these two, the y will be eliminated. So 2x plus 2x is 4x, y plus negative x, and then y plus negative y cancel. And positive 3z plus negative 2z is z. 17 plus negative 5 is 12. So these two, we have two equations to unknown. We take it, use elimination. So you multiply the first one by 4. We eliminate x. So 8z minus z is 7z. 40 minus 12 is 28. And we solve for the z is 4. The z is 4. You put that there. And this is that we put 4 here. And we solve for x equal to 2. Then we use the original one. So say any of that, x plus y plus 7. You take that. For x, we got 2. For z, we got 4. We just rearrange it for y. As you see, there is a point of intersection. Okay, here is another example. You have 3 plane. What we do, we check the normals. The normal here is 3, 15, negative 9, 6, 30, negative 18, 5, 25, negative 15. As you see, you can factor out 3 here, 6 from here, 5 from here. They are all multiple of each other. Okay, so we want to see if they are distinct or they are the same. So what you do, you can divide this one by 3, right? You can divide this one by 6. And you can divide this one by 2. Okay. As you see, 2 of them, if you do that, 2 of them will be the same. Smart, so let's do that there. They are multiple of each other. This one divided by 3 would be what? 4, right? 24 divided by 6 is 4. 10 divided by 5 is 2. As you see, the first one and second one, they are the same. But so the first 2 is the same, but it's distinct from the third one. So it's just going to be 2 of them is the same and 1 distinct from that. So technically no solution. Okay. Here is another example. We want to take the first one, second one, third one. We want to see, so they are not parallel. If you see, if they are not multiple of each other, if you multiply this one by 3, you won't get the second one. You won't multiply, and the first one, third one is not the same. They are, the n of them is not multiple of each other. So not parallel. So we want to check if they are coplanar or not. So you take the normal of the first one and second one, you cross product. You cross product the second one and third one. The normal of that is there. And you dot it to the first one. So as you see that they are coplanar, it could be a line of intersection. So what we do, we take the first one and third one and eliminating x. So first one, third one. So minus them to eliminate x. 3y minus 2y is y, negative z minus 2z is z, 4 minus 8 is 8. Also, you're taking the second one and third one, and then same thing, you eliminating the x. Eliminating here, so you get y positive is the same as what we did before. So therefore, it is a line. So instead of the y, you put t, right? And you put you find y positive equal 8. Instead of the y, you put t. You solve for z. Z is that. And you can use one of this equation. Any of that is acceptable. Let's just do x plus 3y. This one, the first one. And it says equal 4. Instead of the y, you put, and instead of the z, you put 8 minus t. Instead of y, you put t. and then you solve for x. This would be your x, y, and z interrupt. This is parametric equation of that line. Then you can write the vector equation of that line. So here it would be 12, 0, 8 as a point. And the directional vector going to be -4, 1, -1. Directional vector that's multiplied by t. Okay. So for the worksheet, so these are all types that you can go and look. Determine the line through the rigid planes. Okay, you can do 1A, 2A, 3A, 4A, 5A, 6A,